Okay, so now we're going to combine what we just did in terms of being able to convert our vectors into Cartesian notation. We're going to combine that with what we did before in terms of resultants. So take a look at this one. It says, determine the magnitude and the direction of the resultant. So that means we're going to have to add them up. That's what it means when it says resultant. All right, add them up. And then once we've added them up, then we got to find the magnitude and the direction of that. Okay. So something you need to start to train yourself is when you see the word magnitude, that means you are most likely going to end up somewhere doing Pythagorean's theorem. Okay. So you're going to need some X components, some Y components, and then you're going to go with that. And then you're also going to need the direction, okay, that goes with it. So let's pretend for just a second that maybe my resultant, if I add all these things up, is pointing off in this direction right here. Okay, well, that means I'm going to have for that particular vector, I'm going to have an X component, and I'm going to have a Y component, like that. And so in order to get the magnitude, what I'm going to need to do is I'm going to need to say that R is going to be the square root of Rx squared plus Ry squared. Okay. And then to get the angle, I'm going to use rise over the run. I'm going to say that the tangent of theta is my Ry over my Rx. Okay. So if I can get Rx and Ry, we got it. Okay. So let me erase a few things here. I already made my drawing messy. So let me get rid of my notations here. Okay. The vectors are not labeled. That's yucky. Let's fix that first. So we're going to put some notations in here. So maybe we'll call this guy A, and we'll call this guy B, and this one we'll call C. Okay, just to be consistent. So I got A, B, and C. So I've got to take vector A, and I have to put it into Cartesian notation. So in other words, I'm going to need A is some combination of AX and AY. Okay, so that's just what we did in the last video. And you can see we've got the 3, 4, 5 triangle there. So AX is the one that's going to go as cosine. And so our cosine then, in this case, given this particular triangle, cosine of theta is going to be 4/5. So I'm going to have A onto 4/5, comma, A. Now A is the magnitude, so A is 250. And then sine is going to be times 3/5. Okay. So if we put our numbers in that, then we're going to have 250 onto 4/5 and 250 onto 3/5. Okay. So that works out to be 200 and 150. Okay. Now, some of you had a little red flag there. You're like, whoa, wait a minute. Because AX is to the left. Okay. AX is to the left, which means right here, I actually need a negative in there like that. It should be negative A 4/5. Okay. So remember what I said. You get to the end of that thing, double check left and rights, up and downs. That's what I did in my head. And I was like, oh crap, I messed that up. I got to go back and fix that. So here's here and there's there. So there's my vector A. Now I have to do the same thing for vector B. Okay, so vector B, Okay, we're going to have bx comma by. And vector b is the one that's at the 30-degree angle. So that means we're going to have, I'm going to go ahead and put some numbers here. We're going to have 400 cosine of 30, 400 sine of 30. And when you run your numbers on that, what you're going to get is 346.4 and 200. Okay, now, pro tip. The sine of 30 is going to come up a lot. You are going to save yourself hours of time over the course of the semester if you just flat out remember that the sine of 30 degrees is a half. Okay, so I got 400 times a half, boom, 200, boom. I don't have to calculate it, boom, it's just right there. Okay, let's get the very last, let's call it C, and vector C is lined up right along my x-axis, and so it only has the x component, and so I've got 300 comma 0. There we go. There's that. Okay, so I need to make just a little bit of room here, so I'm going to move some stuff around. Okay, and I'll put a little line here. That's good. That'll help too. Because now I got to get Rx and Ry. Remember, that's our goal. If we get Rx and Ry, then we're good to go. So how do I do that? Well, what I'm going to do is I'm going to add up my vectors. So I've got vector A, B, and C. I'm going to add those guys up, and they're going to give me R. Okay. Now vector A, if I copy that over, I've got minus 200, comma 150. And B, I've got 346.4, comma 200. And then for C, I've got 300, comma 0. Just like that, okay? Now, be kind to yourself, okay? Make these things line up, because that's what we're going to do. We're going to add them, all right? So, again, if you keep your paper organized, it's going to help your brain stay organized, okay? Organized paper, organized mind. They go together. They go together. Don't get sloppy. All right. So all I have to do up is add those things in columns. So we get here 446.4. Don't forget that it's a negative 200. Watch out for that. And then 350. Okay. So now I've got my Rx and I've got my Ry. Here's Rx. Here's Ry. So we can come up here. And when you put in your numbers for Rx, I'm not going to burn up space on that one. But when you plug in your number Rx and Ry, what you're going to end up getting is 567.3. And down here, once you do your inverse tangent, you're going to get 38.1 degrees. Okay, so see what I mean? It was kind of like a blend of what we've done previously with resultants, plus what we've done with the Cartesian stuff. Now, just imagine when we were doing resultants before, we only were dealing with two vectors in a shot. If we were going to try and do what we did before, what we would have to do is something like this. It would not be pretty. We'd have to take A and add it to B. All right. And then that's going to give us some intermediate resultant. And then we'd have to take that intermediate resultant and add it to C. Oops, sorry about that. And add it to C like this to get the ultimate resultant. Like that. So it would be a two-step process. So all that stuff with law of sines and laws of cosines, we'd end up doing all of that twice for each step. Okay. And it's doable, but what a mess. What a mess. So converting into Cartesian is much simpler. All right. And now that all of you are experts at laws of sines and laws of cosines, we're going to end up doing it this way the vast majority of the time. Okay.